degree, and I'm a lawyer out here in Washington as well, although I don't practice a lot. I do a few arbitrations and things like that, but sort of a part-time volunteer effort for the most part. And so anyway, I've been working with Michael for quite a number of years, actually, now. Michael, we've known each other for a long time.
Yeah.
And done some, Michael's trained me on how to do code changes and proposals, and I've had a lot of fun with that. So, yeah.
So how about you, Craig? You want to tell Rich what you know? By the way, guys, for the benefit of our colleagues, we find that we get usually 10 times as many people listening to these on demand as actually in attendance. So it is being recorded. We'll probably run over, but let me make sure that I get on the screen here what we're actually going to be looking at and discussing. This might be one of those conference calls where, since nobody's met each other, where we will probably do a lot more talking than showing. So I'll just restate the goal here is to get ideas, enough of a agenda item on the committee, on the International Plumbing Code Committee. I believe they meet in, we have a deadline of something like mid-January, and we've been circulating different ideas. So probably the last teleconference we have before we submit our statements to them and our recommendations. So just be aware of that. And these are, as always I say in these teleconferences, they are not, these are the unrefined moments. This is what the skunk works of code writing is all about. So nothing polished here, but we hope the raw intelligence in the room right now will guide us here. So Steve, do you want, since you're going to be here the least, you want to say something about what you do and how we've been interacting over the past few months on this?
Yes, hello. I'm the Master Plumber of Record for U of M. My title is Plumbing Program Manager. I do have an engineering degree in material science, but really I'm an overeducated plumber. And so I get involved in plumbing policy on various levels, and I have a pleasure of knowing Mr. Anthony here, and we mix it up from time to time. So hello.
Mix it up is a fair point. Yeah, okay.
Yes.
I like that. Craig, how about you?
I'm kind of an accidental participant. I've been in HVAC here at the university all my career, almost a third of a century now, in a couple of months. But I'm actually, all I have is a philosophy degree. So I'm way out of my league with these highly titled and credentials.
Oh, I don't know.
I don't think so.
I have read our plumbing.
Yeah, I think you might be pretty well prepared. So
Yeah, no,
okay.
you get to that point.
All right. So anyway,
All right.
that's all I can offer. So.
Okay, so all we need in the first of two phases to get an idea discussed is something with enough credibility to pass to the first screening committee of the IPC. Unlike other organizations like NFPA, we have to have a solid enough concept, and I think we do. We're simply asking for more granularity in the way we describe maybe fixtures or occupancy classes. How you assign, and Steve tells us that how you assign the actual pipe width per fixture is not as negotiable as it is as we start to accumulate the demand and we get into other parts of the design equation in which now you're left to decide what size should that pipe actually be. And maybe you want to say a little something about that before. You've almost reached the limit of my knowledge because that sounds an awful lot like what we do in electrical.
yes, what I was telling Mr. Anthony was that it's going to be tough to debate how much water any one fixture should be allowed, the minimum amount of water for usage on that fixture, because that fixture was designed by a manufacturer, and then it got a rating, and a team of people already decided that that fixture needs a minimum amount of water. So it's pretty well established. However, when you put 100 fixtures together in a building, and then they're sizing the water service for that building with those fixtures in it, that is not quite such a regulated pipe size. And what I've noticed here at U of M and in the state of Michigan overall is that for many years, oversizing these main services and main distributions and buildings is quite popular for expandability or for whatever reasons. And I've seen a lot of oversized stuff. That's pretty much my point, is that my focus as a plumber would be more on the main piping, the larger piping, less on the fixtures, unless somebody points out something different to me in that regard.
Yeah, I haven't done plumbing design in a number of years. Do you think that the size of pipes pursuant to the IPC or International Plumbing Code, has it gone down because of low flow fixtures, or have they stayed the same?
I think it's, I can't say I'm completely educated there, but I think they've stayed the same.
It is not. That's the point here.
And that's kind of our point, right?
Yeah.
Yeah.
So if you look at this, Ted looked at this and he said, we don't have any showers that are 3 gallons per minute anymore. What are you doing in there? Get it out of there.
Yeah.
Now we're talking about showers where? Is that a shower in a residence? Is that a shower in a commercial building? Is that a shower in a student residence facility? So right away, one of our proposals contemplates getting more granularity here, because all you're seeing, you know, there's laboratories in different types of buildings. You can have laboratories in football stadiums, right?
Yeah.
Yeah, and if you, I'm assuming you can see what's going on the screen here. So right away, this flow rate here, you know, we come and make that committee say, look, it's not sufficient just to have 2 types of showers. This table actually needs to be occupancy informed. Is that fair?
Yes, fair.
A shower in a gas station for the mechanics is different than a shower in a student residence facility, and yet we're stuck with this.
Well, in your new buildings, you have to put in the low-flow shower heads. You have no choice.
Yeah, so regardless, I think, of the type of shower, your code is really going to say 2 gallons per minute.
But it's not. It's saying that.
Or that's the state codes I'm aware of, right?
This is Michigan Plumbing Code. This is the one we are actually enforcing right now. This is what they're designing.
Oh, that's Michigan.
Now, this is Michigan. What's the knockoff of the? Again, I have the national. Here's the national. What is that? It's table. They're virtually identical. You guys know this.
Yeah, typically what I've seen, Michigan.
There we go.
Yeah. Now, if I recall, one of the strategies for doing this work is to add up the flow rates per fixture when you're sizing your main lines. If I, you know, again, I haven't done this in over 20 years. It's been more than 20 years since I've done this, actually, closer to 30. And I've done it before, but, you know, I'm having troubles remembering how to do it. But I think I used to add these flow rates. There's a diversity in there, though, somewhere. I don't remember how we accounted for that. And then we'd look at the very charts in the old Uniform Plumbing Code, and we'd say, okay, I need this flow rate with this pressure drop, and I'd pick a pipe size. And I'm sure we were always oversizing, as you've stated, because I think we didn't account for all diversity that really existed, and we certainly didn't change things when we went to low-flow fixtures.
And that would be a logical engineering approach, right? To goodness, make sure that you have enough capacity for water, power, whatever, as you're supplying your building, right? And that does make sense. And now you could even say, I think, that technology has involved our ability to track these systems, and their install has evolved enough where I think we could have some savings in being diligent and you know, looking to minimize sizes instead of maximize them, if you know what I'm saying.
Oh, absolutely. Well, and I think one of the things we do as engineers is, and Michael, I think this is similar in electrical engineering as well, the less we know, the more we oversize.
Mm-hmm.
Yeah.
Yeah, absolutely. Yeah.
Yeah.
Well,
yeah.
now I'm looking at something here. This 2000. So we were looking at the 2012 Michigan Plumbing Code. Now we have the 2015 IPC, and I'm still hearing people come on and off here. This says 2.5, so this is a little bit more in the direction. Now let's see what it says for B. Where the shower mixing valve manufacturer indicates a lower flow rating for the mixing valve, the lower value shall be applied.
There you go.
Okay, so it looks to me like what they've done is from the Michigan Code, which is based on 2012. So what we're looking for, we're trying to mark up for 2018. So we've already got, looks like a half gallon per minute. They've already shaved this
So they reduced that, and then they're saying that they're but they're also saying use whatever the manufacturer tells you, essentially, right?
Yeah, which is the shower valve itself.
Yeah.
Right.
Yeah.
Another limiting factor there. And I apologize, I don't have my own code memorized, but 2.2, that's the number that is in my head all the time. 2 gallons per minute or 2.2 gallons
For
per
a
minute.
shower?
For any shower.
For any shower. Okay.
Yeah.
Well, this is not that far off. It's better than 3.
Yes, it is.
Okay. All right. But that still doesn't, so let's say this is moving in the right direction for us, and we could go in there and say it's 2.2, wherever that number came from. We still have the occupancy and usage
Well,
problem.
that's where your
to deal with.
diversity number comes in, and that's where the art of the thing is, right? I mean, so you to be able to figure out a good diversity number, the diversity number is what determines
Right.
whether you're going to have heavy usage or light usage.
That's right.
And
That's right, and that's what Larry had, since Larry's not in, and he wrote that article for facilities manager, if you recall, about last year at this time. And he had said that this was a design issue. And Larry, I know you're going to be listening to this recording, so I do know it's a design issue. But I am going to put new ideas on in front of that committee by hook or crook. And if I can make them think a little bit more about whether or not it's appropriate to say in here, and this, whether this table should be broken up and more granular about the type of occupancy that it's in here, or should we continue to put it wherever that diversity factor is in here? And I don't know.
I think
think
there's a
diversity. Go ahead.
I think there's a table in here, at least there used to be, that had the total fixture count and what the supply had to be for that. And that's where your diversity was. This is a vague recollection, but I think that's how they did it. So that, in other words, once you got to a fixture count of 200, you had to have a pipe size of so much, or you had to have a flow rate of so much. Or I don't quite remember how they did it, but it's not at the fixture level where they do that.
Yeah, I see. Okay. For
Yeah.
fixtures adding, now this is for sanitary. We haven't started talking about sanitary.
Drainage fixture use are typically a sanitary measurement. And I can't quote it right now, but there certainly is language in the Michigan code book for pipe sizing and flow rates. I couldn't nail it down right now, but it's in there.
Yeah.
Okay. All right.
And Michael, on the waste side too, they do. What happens is you get this whole range of fixture unit counts per size of drain pipe, and for example, by the time you get to 4-inch, the fixture counts are very high, and 6-inch it's extremely high, and that sort of thing. So that's how they do it there. I think it's similar in the plumbing code actually.
Okay. So
yeah.
when they say, so here we are this is the plumbing code, and you're seeing, I love this statement. If it were more prescriptive, I would ask for it to be relaxed. Now that it's relaxed, I would ask for it to be more prescriptive.
Of course not.
So
yeah, of
here
course
we
not.
are, just design according to accepted engineering practice. And they even go to the trouble of putting it in italics. So as an inspector, Steve, what does that look like to you?
Well, in this case, the inspector, if he's looking, first of all, I have never seen one inspector in my entire career inspect for a pipe size. Okay?
yeah,
Unless it was a 3/8 supply feeding a flush valve for a toilet or something crazy like that. But inspectors don't measure pipe sizes. So I would say that means that a good set of drawings would need to be provided for a new construction or a renovation. And then if the inspector wanted to enforce that, he would look at those drawings, and they would be the source of his inspection, right? To see that they meet what the drawing says. Other than that, I've never seen an inspector address pipe size. No. Things like pitch and positions of fixtures, water temperature, and the finer venting. That's what inspectors.
That's a safety issue.
Yes.
Whereas the pipe size is an economic issue.
would it be fair to say that your pipe sizing is also because basically what you typically have is you don't have custom pipes. You're going to buy something off this.
Correct.
A standard thing.
Correct.
You're probably going to be in the next group up. I mean,
Exactly.
I mean, you're
Exactly.
not the fact of the materials available pretty much almost determines that you're going to wind up oversizing things anyway. Because there's a huge difference between 3/4 inch, tubing and half-inch tubing. And if you're in the area of the half-inch, a little bit more, you're going to go to 3/4. And you're, in fact, I've got so people also were doing design, so I guess maybe it's more now. I know that when I was learning how to size, ducts and try to balance hydronic flows and things in systems, you just didn't have the computing power that you do now, right? The software, you can now put in your calculated loads in each room and your latent and so forth, and come up with we'll do all kinds of computation. Before it was a matter of you design or run a duct and then you kick it down 2 inches and then you added another 10 or 15 feet or something like that, because you just didn't have time to do all that. All that calculation. So you were really just pasting rules of thumb on here, and I think that's where the fixture count stuff comes from. Precisely. It was just, no one has the time to a whole week counting up all the fixtures and all the runs and computing the pressure drop for the longest running flow out from wherever the main is to the last fixture.
Yeah, you wear out your slide rule, for goodness sake.
Yeah.
So I have to run. Let me make a departing comment.
Yeah.
Okay. And just on that line of logic, and from what I heard Rich say, right? Yeah, you bump one side up.
Mm-hmm.
I've done it myself in the summer before too, and it's obvious to anybody who does algebra. But let me just remind you of the math of the issue. Okay, you go from 6-inch to an 8, bump up to an 8 on your main water service or whatever. Okay, and to a tradesperson and most people, 2 inches, whatever. Okay, that takes you from 28 to 50 square inches of area on that pipe. That's nearly like a 40% increase by going the next size up, right? So I think we're on.
Glad you know pi.
Exactly.
Yes, well, I went to engineering school, so
Okay.
I had a whole class on 5.
So I got a great combination here. I think Rich installed you guys very well. You got a philosopher, and he's far from a philosopher. And we got an engineer. No. You're more than a philosopher. Sorry about that. Yeah.
I'm sure he had you in mind when he hired us both, Mike.
That's right. Okay.
I have to run, guys.
Okay, so you'll see this draft. You know where we're going with this.
Yes, I do.
All right, very good.
It almost.
Take care.
You can sit here. So
Yeah, thank you. Bye-bye.
Thinking about this, I mean, it's the.
If I'm seeing this correct,
I also. I don't
yeah,
know,
if I'm,
kind of an anecdotal thing. I remember I was on this doesn't apply to some other things. So, for instance, I was on the board of our swim club, and we were replacing the pumps and things. And the guy they hired to do this, right? He didn't bother even to take pressure drop readings over the existing piping, and it would have been a very simple thing to do. And what they wound up was, of course, the pumps were way undersized for what the piping was, because this wasn't covered by the code. So by the plumbing code, right? This was just circulating piping through, and he couldn't get the circulation rates that they needed for the pool. And I asked him, well, didn't you just take the measure? He said, well, maybe you guys at the University of Michigan have time to, do a lot of math and calculations, but I'm in the business, right? I have to go out and just, bid these things and turn them out. So I think maybe that's, maybe on a big project where you're actually designing a World Trade Center or something, they have the engineering resources to spend the money to actually try and shave a couple $1 million out by doing it right. But in a lot of the real world, it's just some ordinary people without enough staff, because they don't have enough resources to pay people for the time, and they're trying to get it done as quickly as possible using whatever heuristics they can pull out of their pockets. And so in a sense, I guess, making the plumbing, one of the big purposes of the plumbing code, same thing with the electrical code as others, to just keep people from killing people by doing something dumb, or just because to save money, right? And give them a rule to follow that'll just simplify their lives. Whereas when you get, so it's almost like if you have, maybe I'm wrong with this, but you've got a big building, you're building a university facility, you're going to be investing, there's probably some threshold level. If you're investing, if it takes more than 100 people to put this thing together, you probably have the resources to really calculate it properly and do the best you can.
It's
you're down to 2 or 3 people in a group. You just don't have time or resources.
Yeah, and that's what happens when an architect farms it out to an M&E firm to give them a certain amount of hours. But also remember that in our industry, a lot of what happens is renovations. So we'll have, so if we were to ask a question, are the tables different? In the NEC, for example, there are some switches we can throw in the code that allow us to do different things in the renovation scenario versus when we're doing a fresh new building with a fresh new set of plans and all that. Rich, you have some? I thought I heard you wanted to break in.
Oh, yeah, you know, along the same lines, actually. If you think about it, if you're trying to right-size a system, a plumbing system or an electrical system or any system, the probability of oversizing it and undersizing is probably roughly the same. And yet the cost of remedying a problem with undersizing is exponentially higher than on the oversize. The oversize, it takes a little more square footage, it takes a little more material, it's nickels on the dollar or it's 10 cents on the dollar, whereas the cost of going in and retrofitting a main in a high-rise because you've undersized it is huge.
But nobody's going to do that.
Right.
Nobody will do that. You'll just be, you may be stuck with a bill, a water bill, or a meter. I think in some ways, one of the reasons we went down this road is we felt that we were getting hammered on meter charges, which were linked.
Oh, okay, that helps me a great deal.
To the size of the incoming pipe, and for us, it's the difference between a 2-inch and a 4-inch.
Yes, because you theoretically can have this. Oh, you're saying, okay, that makes sense, actually.
Yeah.
You get yourself thrown up into a higher, which is the reason, for example, over at PSRP, why we wound up having the problems we have where we could hardly start our chillers because there was a huge issue if they had put in a big enough substation. You may remember if they'd had kicked that substation up one more notch, right? They would have had to spend a huge amount more money. So they kept it right there, but we didn't have the ampacity basically to turn everything on with the emergency generators when they came online. We had a horrible problem with that. So what you're really talking about is maybe it's a big problem is if you're at a threshold line, right? When you're you have these jumps, right? The discontinuity in resource requirements when you're going from one category of something to something a little bigger. That makes sense. That will cost you a lot more money later on. So I can see why people want to say, well, let's keep it down because.
Well, we also know that our economies are changing. We know that. The sustainability folks, sometimes I'm not very kind to them, but because they're not specific enough. But regardless, it has had the overall policy has had the damping effect on demand. We are coming on a time constraint here, and if you don't mind, I'll give Richard a chance. Do you want to respond to that, Rich, what Craig just said?
I really agree with you, Michael. It really helped me when you mentioned the meter issue that gave rise to this. I just have a little anecdote with respect to meter sizing. It's on the steam system, but some years ago we added some steam meters on some of our branch lines. And to keep the meter working well, we reduced the size of those meters and the piping leading to them so that we could measure it. And it works really well, except when we get into a high demand condition, our pressure drop at those meters is too high. And so we don't get enough steam when we need it. And it's very interesting to see what's happening. And so one of the suggestions I've made is to parallel some of these with second meters. But if we don't shut that second meter off in the summer, we're going to have inaccurate flows and inaccurate measurements. So it's a very similar issue. I think you could reduce your service size. Then you take a pressure drop at that meter during high demand periods on the water system. And when you do that, you end up increasing the size of your piping throughout the system because your pressure drop is higher at the meter. So you end up with a real engineering trade-off. Yeah. That's all I want to say.
Well, that's control turn-down, basically, right? What you're talking about. I'm not sure what this means though, as far as the codes go. I guess it is. I think what Mike is saying is that we design things to use a lot less than we used to, and that's certainly true. I just put a new toilet in my house that uses a lot less water, but it flushes much better than the old one did, believe it or not. So we are designing stuff to be more, to use less fewer resources, and that does mean you don't need so much of the other, issues
Correct.
there.
I agree with you. Yes.
Yeah.
And you get to this
Okay.
right sizing point too.
Well, yeah.
You're probably not going to change. You're probably not going to change the behavior, right, and the design practices of the smaller jobs, right? With the plumbing code, there probably have a fairly small changes there, unless you have something in there where you force people to buy something they never would have done before. But the big stuff, you can have a huge impact. Of course, that's what we have, right? Here at the university, we don't do anything if it doesn't cost $40,000 or $100,000.
Well, our mechanical contractors will always meet with us and talk trash about our projects, about how we gold plate them all.
Yeah.
And you and I are continually made our careers.
It's gold plated until you actually have to fix it a few years later.
Well, yeah. Okay.
Yeah.
Yeah. Okay. Well, look, guys, there's just a few other housekeeping items I'm going to deal with. You'll see Larry's not here. This was supposed to be authored by Larry, and God bless him. I hope he's sleeping it off. And what you'll do, if you want, Rich, you can be in the loop on this one. I posted on the project website right here. You'll see that we have a number of proposals actually in process here. So this is the I haven't uploaded them all. As usual, I can't get into. There's a lot of things. I can get into 1/10 of the things that hit my radar. So we're going to focus on this one here. We feel it's a little bit more meaningful. Larger because we run into this problem right here with stadiums. I know there's a fair number of stadiums that we run into. And I do think that getting some more specific occupancy information here might be helpful. I mention that because we are doing, where am I? This is the plumbing code. Over here, you'll notice that this is the building code. This is this is not. And I have several subscriptions. This subscription I don't feel like logging off on. I do have the 2015 IPC that we could mark up, but they're virtually the same. But we understand that that a K-12 school, for example, is going to be different than a. I have to make sure I navigate this correctly. Did I just do it? To cut to the chase, I'd like to see more specific occupancy information, and I'm going to say that a reasonable thing for the committee to discuss, and it might. That's my video guy. Oh, by the way, these videos will be better. Here's his contract. It's taken a while to get that going, but I do think that we could open a discussion on some of these about getting them more granular. I know it's a rejectable concept because this all looks very nice and clean, but they do make an occupancy statement right here.
Yeah, I was going to say you see some elements of that already when you say residential and commercial.
Right. So what about a kitchen? What about a kitchen in a restaurant, for example?
Yeah.
That's the kind of stuff that we thought we would do, but I have to pick and choose where we spend our advocacy resources, and because number one, we do so much renovation, and the tendency, first of all, to deal with occupancy differences here that aren't really completely captured. And the other one is how do we accommodate what we do in renovations? That's one area I don't know. What happens after you've laid out a building over time and you've made, say, a laboratory building? What is your experience, Craig, with the renovating and the condition of the domestic water piping system, either from a maintenance standpoint or whether it's functionally?
Well, if you're talking about what we see in domestic water piping systems, especially this is the case when we have the galvanized system, right? What you find is occlusion, right? There is an argument, I guess, to be made that if you want to oversize your supply distribution, you're going to get more effective life out of it because. And this may not be the case in every environment, but it certainly is the case here in Michigan or any other place where there's any serious amount of groundwater, I think, where we get, there's a lot of, those pipes become atmospheric, right?
Well, but isn't there also a counter argument to be made that when you, I put in a proposal for the feds want to get into the hot water heater business. There's somewhere around here. If our pipes are so vastly oversized that now you're spending all the energy that you think...
pumping it around to keep it warm.
Yeah, to keep it warm. If you don't have a reheat system, system. Where's that one? I think it's somewhere right here.
Reheat at point of use.
Right. This is the. I think we did this last. So this is this deal here where they want to regulate. They want to regulate more of the water heater system. So I mention it only because you have these force and counter forces where you have to deal with the reasonable desire to save energy, and you just made an argument why you'd want the pipe larger, but now I've just said,
well,
you
just
got another
only
problem.
because eventually it's gonna get worse. I mean the.
Oh, you're saying
Yeah.
when they're bigger, it causes
No,
arthrosclerosis.
it doesn't. But what it means is it's going to take longer for it to block up.
Yeah.
But that's really not a problem with modern piping. I mean, nobody's specifying galvanized anymore.
So go ahead, Rich.
No one is specifying galvanized anymore. I mean, I don't see it around.
No,
But
we don't use it anymore.
yeah, and with the galvanized piping we find the problem with the smaller sizes. It jams up.
Yep.
It gets to, so you have a thread of a channel, a capillary, basically, through there.
Yeah.
Yeah, so, and we're having to replace it in some of the older buildings.
Yes, we are too.
Yeah, of course, yeah.
We've got some stuff, though, where the buildings they're 30 or 40 years old, which I can now remember that. I mean,
Isn't that sad?
Yeah.
so almost.
I've been 82. When were you here? 82?
I was 82.
Okay, great. All right, for the same vintage. Okay. Well, look, guys, thanks very much for your time. As always, we only have a certain amount of time we can spend on consensus building here. This has been around since July or so. When did we start yabbering this one? Actually, May.
Where are the big changes? I mean, do we have something that differentially shows the changes and alterations?
Well, that's what this was supposed to be here, and
And then
you can actually
highlight those.
I actually, Larry, I know Larry's going to laugh at this. I don't think sure Larry wanted to do this, but I'm saying I'd sure have rather a mechanical guy do this than me. But conceptually, we were following some of his ideas that were summarized in that one article that showed up for him. So I'll do a strike and bold and circulate it to folks, but a lot of the substantiation, how can you let an electrical engineer do a strike and bold and leave it to the mechanical guys to do? Remember, we just have to, we'll have another year to get some more data if we need to get the data. We'll get a sense of where the committee is on it, and I'll try to get somebody to follow it a little bit more carefully. So I did want to, is there anything else you want to add on that before I do my usual closing remark?
I got an email from Larry Spielvogel, Mike, that he could not get on the conference call. He emailed me at 11:24 a.m.
Oh, excellent. All right, so maybe that was him we heard going on and off.
It could have been.
Yeah, so that's why I record these. Everybody sort of has to be nice because as I try to remind people, I'll just give you an example here. Is if I get on our YouTube channel and I'll go to, and I'll just pick one. We have 713 views. I was always amazed at where's our NFPA 13 one where we had where's NFPA 13? Here we go. So they wanted to put temperature sensors on every building, right? So that's about $5,000, and of course we work with 2 here. So what do we have? 4 people on that teleconference in August, and there's 99 views on it already, right? So and we were successful. And by the way, we were successful in turning that back. I'll get this updated, but as of they did accept that. Oops, sorry about that, Larry. But long story short, for how it's meaningful, at least to the University of Michigan, is that we have, for us, we went around and got some 3 estimates. So we're going to say that just the University of Michigan alone, we have avoided regulatory burden of $500,000 to $2.5 million. Now, anybody can throw a ridiculous idea at us, and we can say we stopped the ridiculous idea, and that has some monetary value to us. I get that, and we always try to say that. We also know we're obligated to work within powers of 10 because we don't do everything all at once. But my general point is that this does seem to work. We work, and we are reporting this here and elsewhere. So. Oh, one other thing too, if you're interested, Rich, we have a Twitter feed here now. We just started it last week. We've already got 91 followers. So that's it's turning out to be very interesting. There's a lot of facility organizations that have Twitter feeds now. That's the way they're delivering their that's the way they're delivering and interacting with their customers over here, especially in the way of mass notification.
Are you telling me I'm going to have to start worrying about this stuff?
Yeah, you are. Yeah, well, let's get off this call first. So, okay, so next week I talked to Ted, and this might be the last one I do for MAPA generally. It will be talking about it'll be structural engineering. I believe it's going to be on demand. We have a meeting on the, I believe, meeting we have with the structural engineers on Wednesday. It's right there, and then we'll record that session. We'll post it here for everybody. So that's kind of it. Is there any closing remarks here that you have, Rich?
No, I thank you very much for doing this, Michael. It's been a pleasure, and it's been a pleasure talking with all you guys.
Okay, great. Yep. So this will be on the Worldwide Intertubes in, I don't know, maybe a day or so. I'll stop recording. Thanks very much, colleagues. I think they know where to find us. Take care.
Sounds good. Thank you very much. Bye-bye.